So we've got a stack of cubes, and we've got the first stack, the second stack, the third stack. Now remember, guys, the first thing that we always do, don't even look at the questions. Look at the pictures or look at the pattern and decide what's happening. So in stack 1, I have 1 block. Okay. In stack 2, and be careful, this is a 3D image. So if we have a look here, this is 1 block, 2 blocks, 3 blocks. There's a 4th one at the back there that we can't see. 5 blocks, 6 blocks, 7 blocks, 8 blocks. So this second stack has 8 blocks. Right. Now we go to the third stack. Again, there's blocks that we can't see here, but I've got 3 in the front and 3 along. So if I imagine the base of my block, I don't know why I made the choice to draw it like that. So we're just going to pretend that I've made logical choices here. The base of that block would have 3 by 3, which means that I have 3, 6, 9 blocks per level. Now, per level, per row. So this row has 9 blocks, this row has 9 blocks, this row has 9 blocks, which means altogether I have got 27 blocks in stack 3. Now it's important for us to first just look and see what we have, because now we've got some numbers that we can work with in terms of potentially trying to find a relationship. All right, so the first question is asking us to complete the table below. What I want you guys to do is fill in, and I'm just going to put A, B so that on the chat we know what's what. I want you to fill up to F for me. If you can do 10, that's absolutely fine. So I'll put a little G in there. But what I want from you is the first 6. See if you can figure out what pattern's going on here in terms of the number of blocks that you have. And then on the chat, I want to see answers for A, B, C, D, all the way up to F. Right, so give it a try. Let's see what we get. I've basically done A, B, and C for you already. In order for you to get D, E, and F, you do need to know what the pattern is, but hopefully something from Monday's lesson will come about in our heads and spring something in there. Let's see what we get. Okay, I'm going to give you another like minute or so. And guys, like the one Les put there on the chat, number your answer. Nice, Orchile. Love when we get all of our answers at the same time. Alrighty, grade 8s. So would anyone like to raise their hand to tell me what the pattern is that they saw with these stacks? So what was the pattern that you saw that helped you get D, E, F, and potentially even G? You can raise your hand. If you're not feeling super if you're not feeling comfortable or confident, you are welcome to put it in the chat. I'd like a raised hand because I'd like to hear your voices. But if we're not feeling super confident, what is the pattern? What are we doing to get the number of blocks in stack 1, in stack 2, in stack 3? And I know you know it because you're all giving me correct answers. So that helps the answers that I'm seeing are correct. Anyone want to raise a hand? Oh, great. All right, Motabang has put it there on the chat for us. So guys, basically what we're working with here is English cube numbers. Okay, kind of ironic. We have cubes and we're working with cubes. So what that means is because we know what the pattern is, we can now go and continue this pattern. Now the pattern is essentially if we take stack 1 and we cube it, we get 1. If we take stack 2 and cube it, we get 8. Stack 3, cube it, we get 27. So the stack number we are cubing in order to get our answer. So 4 cubed, as all of you said, 64, 125, 216. And I told you you could try G if you're feeling comfortable. But because we do know what the pattern is, it's easy. We just say 10 cubed. Now 10 cubed, remember, is 10 times 10 times 10, which gives us 1,000. So guys, this is why I always say to you, first figure out what's going on and figure out what the relationship or what the pattern is. Once you know that, answering the rest of the questions becomes incredibly easy. All right, so Chantal? Chantal, your hands up?
Ma'am, I wanted to answer the question.
Okay, well, can you tell me what the rule is?
Ma'am, I said we cube.
Perfect. So your rule would be y equals x?
Y is equals to x to the power of 3.
Perfect. Well done. Okay, so there we go, guys. Chantal has given us our answer for our next question, which is cubing our input value. Now, remember, guys, we've spoken about input and output values before. And we're going to chat about them more later. But when we're working with a pattern, we have these two variables or these two values that we're trying to find a relationship between. Clearly waking up at 6:30 is doing nothing for me. So our rule here, y is equal to x cubed. Now that's all fun and games, but what is x and what is y? So when we're talking about a number pattern, x is the term number. So the first, the second, the third, the fourth, in this case, first stack, second stack, third stack, fourth stack. The y, which is then our output value, is in this case, the number of cubes or the actual term. So let's say we had the pattern 1, 2, 3, 4, 5, blah, 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 blah. These would be all of our output values, and x would be first, second, third, etc., etc. It's a bit confusing, this example I've given. Let's try another one. X, Y, first, second, third, fourth. Let's go 5, 7, 9, 11. Okay, so Y is your output or your term. X is your input or its position. Right, we did speak about this on Monday, which is why I'm sort of quickly hashing it out. We're going to chat about inputs and outputs again just now. But once we know what our inputs are, we know what our outputs are, we find a relationship between them, we are able to find a rule. All right, so I'm going to give you guys a question here that I want you to try by yourselves. And let's see if we can now take a rule that we have and work with that information. So, which stack, I don't spell which there for a second. That's not how you spell stack, is it? Stack will have 4,096 blocks. Okay, so that's my question I'm posing to you. Which stack, so if we go back to the pictures here, which one of these stacks, if I carry on this pattern, will end up having 4,096 blocks? So I want you to try that one by yourselves. We'll get an answer in the chat. And I'm going to preempt and pre-warn you. I would like someone to be able to explain this for me. So once you have an answer, think about how you would explain it. And then if you're feeling comfortable, I'll ask you in a minute or so to raise your hands. I'm just going to give everyone a chance, but I'm preemptively letting you know that I would like someone to explain it for us. Nice, guys. Keep those answers coming. All right. Who's going to raise their hand to explain it for us? Nice. Clearly, I need to pre-warn you. Bonolo, how are we going to deal with this?
Hi, ma'am.
Hi.
And hi, everyone. So, ma'am, I said, firstly, I checked into which stack is it going to be. So, I started from 12. Then I said 12 cubed and it not give me the answer. So, I said 13 cubed and it not give me the answer. So, I skipped and went to 16 cubed and it gave me the answer, ma'am.
Okay, awesome. So guys, one way to deal with this sort of question is, let's not say guessing, but is through a method called trial and error. So Bonolo knew that it obviously had to be greater than 10, and so picked 12. And so as you start to use trial and error, you're able to eventually get your answer. There is absolutely nothing wrong with that method. As our patterns become a little bit more complicated and our rules become a little bit more complicated, trial and error is slightly trickier to use, but there's nothing wrong with the method, right? So Bonolo thought and so, okay, it has to be more than 10. I'm going to pick a number. Let's see what happens, and sort of went from there. Absolutely. Chantal, did you do it differently?
Yes, ma'am, I did.
Cool. What did you do?
I said 4,016. 96 cubed, and x to the power of 3 cubed.
Okay. So you substituted into your equation.
I substituted though.
Good. And so
And
what
then
did you get? Sorry, yeah?
Then I cubed them both, and then I got 16 is equals to x.
Perfect. Okay, so guys, if you are going to go the other way and you're going to use substitution, remember this is an equation. And so we're going to use those inverse operations. So what we do is we're going to cube root both sides, because remember, cube root gets rid of a cube, inverse operations. And we did do these types of equations. And exactly as Chantal said here, if you now cube root 4,096, you get that x is equal to 16. So that means that stack 16 will have the 4,096 blocks in it. Nice, Chantal, well done.
Okay, ma'am.
Okay, so guys, there are definitely different ways that you can deal with these questions, whether it's through trial and error, which as you become more comfortable with using the rules, we sort of tend to not really use, but there's nothing wrong with it. Or through solving an equation, which is definitely the route we're starting to gear towards. But at these beginning stages, particularly in grade 8 and grade 9, there's absolutely nothing wrong with just using logic to try and find your answers. Alrighty. And what you're going to start to find later on, especially as you get into like grade 10, 11, 12. So when it gets to problem solving sorts of questions, number patterns and relationships is actually one we really like to give you problem solving and more tricky questions. And then logic is really important. Like sometimes just logically thinking about the situation will get you the answer. There's no fancy stuff you need to do just because it's a harder question. Thinking logically allows you to get your answer. All right, so very nicely done. I saw a lot of 16 or x equals 16 on the chat, so well done for getting that. But this is essentially just rehashing what we did on Monday, understanding this idea of having two variables, x and y, and that there is a relationship that exists between those two variables. So I'm just going to make this a touch smaller for you guys to screenshot. If anyone has any questions, now's the time to raise your hand and ask me. Remember, guys, you obviously are welcome to put your questions on the chat. I have the chat open. Yolanda has the chat open. We will deal with your question as soon as we see it, which is pretty much instantly. But otherwise, at this point, please do raise your hands and let me know if you have questions. Otherwise, we're going to move on in a second. Okay, nice. Good, grade 8s. All right, so what I sort of want to chat about, and I'm going to try to come up with another one in a second, is just some scenarios of how different values can affect each other, because this is essentially what we're looking at here. We're looking at a situation where we've got two values. They have a relationship between each other, or with each other rather. And what is that relationship? Okay, so the first scenario that we have here is, and I'm going to try to get my English correct here, is the number of calls you make and the amount of airtime, and I'm not actually going to say you have, let's say that you spend. All right. So if we think about this logically, are you going to spend more if you make more calls, or are you going to spend less if you make more calls? So on the chat, tell me, if you make more calls, do you spend more, or do you spend less if you make more calls? Just like, again, like use your logical brain. In terms of the amount of airtime you use, if I make 100 calls versus 50 calls, does making more calls mean I spend more airtime or less airtime? Okay, I'm going to say my question again, because like I say, my English is, I'm not an English teacher. Are you going to spend more airtime making more calls, or are you going to spend more airtime making less calls? I can't even remember what I said now. Right, let's put it into an example. If you made 100 calls, do you spend more or less than if you made 50 calls? So essentially, the question is, what is the relationship between the amount of calls you make and the amount of airtime you have to buy or that you spend? Do a quick Google here. Okay, I think we're all on the same page and we all understood me in the end. The more calls you make, the more airtime you spend. So let's put that into words. So the more calls we make, the more airtime is spent. You know, obviously different cell phone providers have different rates. if we look at Vodacom is 79 cents per minute. Okay, so let's just use some actual numbers here in order to figure out what this means. So if you spend 1 minute on a call, you're just going to pay 79 cents. Okay, nice and straightforward. There's nothing wrong with that. If we spend 2 minutes on a call, we're going to have to double that. And double that would be R1.44. If we spend, let's say, 10 minutes on a call, we'd have to times that by 10. Oops, 10-minute call. And so we'd have to spend R7.90. And so what we're seeing is that the more call time we have, the more we spend. All right, and that's an example of a relationship that exists between variables. Now, I've given you an example already of something of a real life application in terms of a business and profit, right? A business would look at how much money they earn, how much money they spend, and what is the profit that they make. That is a relationship that exists between two variables. This is a relationship that exists between two variables, the number of calls you make and the amount of airtime you spend. There are relationships that exist across several different examples, right? We could think of your marks versus study time. Hopefully, the more you study and the more effectively you study, the higher your marks. We could have a look at I had an example in my head and now it's gone. Electricity tariffs. The more electricity you use, the more you're going to pay for your electricity. Water, the more water you use, the more you're going to pay. So there's so many different real world applications of this. And so if you're going to do maths, you're going to deal a lot with graphs. But if you're going to eventually decide to take maths lit at some point in your life, maths lit looks a lot at how these relationships exist between values, and particularly in a real world example. All right, so it's really important that we do understand these relationships and that we can start to see these relationships. Zandile, I do see your question. I will go back to the first ones in a second. Once we've finished having this discussion, I will go back for you to screenshot, okay? So do remember everything's recorded. You can go and rewatch the recording if need be. All right, so guys, let's have a look at the second one. The number of matches in each picture and the number of triangles created. So what is the relationship? Essentially, if we have more matches, can we make more triangles? Yes or no? So if I have more matches, can I make more triangles? And on the chat, just yes or no, or thumbs up, thumbs down, what do you think? So with more matches, can I make more triangles in this pattern? Nice. Okay, so again, a relationship exists. The more matches I have, the more triangles I can make. If I don't have those extra matches, I'm not going to be able to make more triangles. So all of these relationships exist and we need to be able to identify them. And now when we get to looking at different types of variables, we have to be able to identify the variables that allow these relationships to exist. Okay, very nice. I'm trying to think of an example where decreases. I have to think. Right. But essentially, we have different types of relationships. We have different variables, different values that have these relationships, and we're going to now start working quite closely with how to represent those relationships. Okay, so guys, just quickly, if you didn't get a screenshot of the first one, here it is. I will go back to the airtime example if you want to screenshot that. But otherwise, we're going to look at types of variables and how we're going to start applying. Now, as I've said to you before, this section has applications in number patterns, graphs, functions and relationships, ratio, rates. Honestly, we can link it with equations. As we've seen, our rules are equations. There's so much overlap with so many different sections in math. So it's really important that if we're comfortable with this, all of those other things will start to fall into place. Okay, so I hope we got a screenshot of this. Here is our airtime example, if you didn't catch a screenshot of that. But we're going to look at now how we can take these scenarios and actually apply them or put them into an algebraic rule or statement that allows us to work with them. Okay, so guys, we've got two different types of values or two different types of variables. We can use either phrase to work with it or to describe it. We have input and output values. All right, so we know that we represent input values with an X variable and output values with a Y variable. So two different variables that we work with. Okay, our input value is a value that we apply a rule to get an output value. Right, so for example, if we think about the airtime example, my input value would be the number of calls I make or the number of minutes I spend on a call. We take that specific input value and we apply the 79 cents per minute rate, and we're able to get the total cost for that call. So it is a specific value that we now use a specific rule and apply that rule to get a corresponding output value. Right, now importantly, this rule that we're talking about is describing the relationship between X and Y. So it's not just something that we make up. As you guys have seen, if you think about the blocks example, we didn't just make up the fact that the values were being cubed. We looked at the relationship between stack number and number of blocks. We looked to see how it changed from one stack to the next, and we found a relationship. It was being cubed. We can now take that rule and apply it. So we don't just make up any rule that we want. We look at the information we've been given and we are able to determine a rule based on that information, which means that any scenario is going to have a different rule. It's not like you will work with the same rule over and over and over again, and we've already seen that. But every scenario has its own unique rule that we will then use. Our output value obviously links with the X value, is the value that results from applying our rule to X. Can't write, can't spell. Right, so I'm going to use the airtime example just to make this a bit more real world or a bit more relatable. If we have Y equals 79 cents times X, okay, so let's just take that algebraic sentence and understand what it means. So this Y that I've got here, that represents my output. So this is representing my total cost for a call. X is representing the number of minutes of that call. So I'm going to come back to this, don't stress. If I go back up here to this blue writing, here is my X value, it's my input value, it's 79 cents. And every single time I make, here are my X values, losing my mind. They are the number of minutes I spend on the call. Okay, 1 minute, 2 minutes, 50 minutes, 120 minutes. They are how long I spend on my call. That is going to determine the cost of my call. Those are my output values. They are dependent on how long my phone call is. And so from this information that we had here, we were able to find a specific rule that applies to that relationship. Right, now that was a rule specific to the airtime scenario. If we had a completely different scenario, say electricity, it would be a different rule. It is very much dependent on the context, and we need to be able to do that or apply it within the context. But we have already been doing that. So our input value is the value that we apply our rule to. Our output value, our y value, is the value that results. Okay, now guys, there are different ways of thinking about x and y variables. Another way to describe an x variable is our independent variable. So if you think about your life sciences, you've probably spoken about independent and dependent variables there. Y is then your dependent variable. If we go back to the airtime example, Y, so the total cost of your call, depends on the number of minutes you spend making your call. We can think of our input and our output as independent and dependent variables. All right, so one value depends on the other, y depends on x, and it follows a specific rule according to whatever our scenario is. Right, so take your screenshots of this. If anyone has any questions about those two definitions, please ask me now. Otherwise, I'm going to give you a little stretch break. We're not going to take a full-on brain break, but a little stretch break. And then we're going to have a look at some examples of how we can now take these x and y values and start to look at relationships that exist. And like I say, we're going to start to look at how it relates to rates and ratios and different sort of contexts, and how we can eventually take these and represent them using graphs. Okay, so any questions, raise your hand, otherwise take your screenshots. Okay, once you've done that, let's take 2 minutes, have a stretch, touch your toes. Oh. And then we'll have a look at some examples.
Just Sam, can we unshare your screen? Sorry to disturb, but I want to help Londeka to just see this screen again. Thank you, Londeka. I hope now, can you see something now, Londeka? You can just comment on the private chat. It's okay. It's for me to know that you're okay.
Okay, hopefully we can all see now. And if you're still taking screenshots, just back up so you can still take your screenshot. Have your stretch. Like I say, touch your toes, grab some water if you need some water. I'm going to give you another minute and then we'll carry on. We had to do like this waterproofing. Well, I say we, our body corporate had to do this waterproofing thing, and they use like dyed water to figure out if there's any leaks that exist. And obviously they choose a dye that is just not a great color. And so this is what my patio looked like. I had red dye everywhere. It looked like I had committed a mass murder. And then it just was like laid out into the street for everyone to see. And I was like, sorry, everyone. It was not great. But I did look like I'd committed some crimes. Okay, guys, I hope we've all got our screenshots. I hope we've all had a stretch. Zandile, the one that had matchsticks. We have not done, oh, this one. Oh, it's like, oh, matchsticks. Okay, there we go. Right, guys. So let's have a look at how we can take these variables and start looking at scenarios that apply them. Okay, Zandelia, I hope you've got your screenshots. I'm going to move away now. Cool. Alrighty, so this first example is an example of a rate. Now, we did rates and ratios way back when in like first term. But like I said, there's a lot of overlap that exists with this section and many others in maths. So this is an example of a rate. And a lot of you, when we did do the section, very eloquently or very described very well what a rate is. Okay, so a rate is a value per unit. So for this example, I'm telling you how much it costs per kilogram, right? A rate could be like the airtime, the cost per minute. So whenever there's this per word or 1 unit is this amount, we are dealing with a rate. Okay, so we've got apples are sold at 16 Rand per kilogram. So there's 2 things we're going to do. 1, we're going to fill in this table, and 2, I'm going to ask you for a rule in a second. But obviously, in order for us to fill in this table, we have to put some information in, right? It doesn't help just having this blank table. That means nothing to us. This is now, cool. This is now where we need to decide what variables are we working with. Now, guys, generally just alphabetically, in a table, X will be at the top row, Y at the bottom row. So remember we said X is our input value, or another way to think of it, X is the independent variable. Okay, so we now need to ask ourselves, we're going to work with 2 different things. We're going to work with how many apples we buy, or the number of kilograms that we buy, and then the cost of buying those apples. So we need to decide which is input, which is output, or which is independent, which is dependent. Now, the amount of kilograms that we buy doesn't depend on cost, right? I can buy 7 kilograms. That isn't going to be determined then by the cost. However, the cost is dependent on how many apples I buy. If I buy 7 kilos of apples versus 10 kilos of apples, that's going to affect my price. So because of that, I know that my independent variable is going to be the number of kilograms that we buy versus my dependent variable, which is going to be the total cost. Okay, so we're working in rands. You don't have to put the rand symbol in if you don't want to. But we've got our 2 variables. We've identified which is which. Generally, guys, if you're ever working with a scenario where cost is involved, or you're determining how much you're going to pay for something, that's going to be your Y value. Okay, because cost depends on how much you purchase or how much of something you use. Alrighty, so we're going to fill in this table. Obviously, we need some values in order to fill in this table. That was a shocking lie. I'm actually embarrassed to have drawn that. Let's try that again. We need some values here. Now, what you need to remember, and this is very important, you can pick any X values. Okay, and they can really be anything. Now, obviously, it should be within the context. So unless you are like an apple juice producing business, you're never going to buy maybe more than like 5 kilos of apples. All right, so I'm going to give you some values here that hopefully make sense. And what you're going to do is you're going to fill in the cost for me. So 0.5 kilogram, 1 kilogram, 2, 4, 5. Okay, so I've given you just random X values. But because you know that apples are sold at 16 Rand for every kilogram, you can go fill in the cost. So I'm just going to fill in A, B, etc., in our tables, so that when you give me answers on the chat, I know what's what. So I want answers for these 7 input values. Let's see what we get. So how much does 0.5 kilogram cost? 1 kilogram, 2, 4, 5, 7, and 15 kilograms. use those variables, use that information, and let's see what we get. Again, on the chat, remember to number your answers. Sorry, so that I know what's what. I'm assuming everyone's working it out and writing it down, and then I'm going to get some answers. No, as I said, nice one there. And guys, remember, number your answers. I'm going to go through it in another minute or so.
Let's go, my people.
Nice, guys, you're doing really well. Give me another 30 seconds, get some answers in. Remember, we're going to check, so make sure you have got them written down and you can do corrections as you need to, although it looks like we're all doing really nicely. Yeah. Good. Okay, so guys, there's lots of different ways to do this, and you need to do what makes sense for you, right? We know that 1 kilogram costs 16 Rand. Okay, and so if we're going to now work out the cost of half a kilogram, one way to sort of do this is to ask ourselves, okay, well, what am I timesing or dividing 1 by to get a half? And we know that if we divide 1 by 2, we get half, which means we need to do exactly the same thing to our cost. That's what a rate is, or a ratio. It all sort of works in balance with each other. And so that's why half a kilogram is only 8 Rand. Ooh. Okay. And the same question can then be asked when we start to move up. Now, 1 kilogram we already know is 16 Rand. But now if we talk about 2 kilos, so we know 1 kilogram is 16 Rand. Now I want to get to 2 kilograms. Question I ask myself is, how do I go from 1 to 2? Well, I times by 2, which means I need to times 16 by 2 as well. So because this is a rate and because it needs to go in proportion with each other, we're able to get these values. So 2 kilos is 32 rand, English for a second. 4 kilos, as all of you said, is 64 rand. 5 kilos is 80 rand. 7 kilos, 112 if I remember correctly. And 15 kilos, 240 rand. All right, so we were able to use the information we were given, this rate of 16 rand per kilogram, and we were able to get our values. So my second question to you guys is, what is the rule? And I'm not going to try to write out a whole question. So what would the rule be for this relationship between the number of kilograms of apples bought and the cost? So you have a think. I'm going to ask someone to raise their hand to give me an answer. So I'm warning you now. What would your rule be? I'll give you 60 seconds to think about it. If I asked you for a rule to describe this relationship, what would it be? Nice, guys. Right, would anyone like to raise their hand to tell me what the rule would be? You guys are all getting it correct. If that helps ease your nerves. Oh, guys. Okay, so yes, y, which is our cost, remember we said that in the table, is equal to 16. You can put the rand if you want. It doesn't really matter because we know it's in rands, times x. X being the number of kilograms of apples that we buy. Right, so we have a rule. We can find that because we know what the relationship is. So in the last, you've got 2 minutes and 40 seconds. How many kilograms of apples did I buy if I spent 288 rand? So that is your final question to end off. How many kilograms of apples did I buy if I spent 288 rand? You've got 90 seconds to give me an answer. And I would really like if someone would explain how they got the answer. Anyone want to raise their hand to explain how they got that answer? It is correct. Everything on the chat there is correct. Anyone want to explain? Nice, Chantal. How did you get your answer?
I said 288 divided by 16.
Perfect. Okay, so guys, if we sub in what we know, 288 is equal to 16x. And exactly as Chantal said, we want to know what x is. So we divide that 288 by 16, telling us that I bought 18 kilograms of apples. Don't know what I'm doing with all those apples, but I bought 18 kilograms. Thank you, Chantal. Well done.
Thank you, ma'am.
Right, so guys, again, once you have a rule and once you know what the relationship is between your two variables, you can do anything you need to do.